In this question, we've been told that a car of mass 1.25 tons tows a caravan of mass 0.75 tons along a straight level road. The total resistance to motion experienced by the car and the caravan is 1,200. So the two resistances added together, 1,200. The car and caravan accelerate uniformly from rest to 25 meters per second in 20 seconds. We're given that the resistance to motion experienced by the car and the caravan are in the same ratio as their masses. And we're asked to find the resistances, to find the tension, and to calculate the driving force. As always, I'm just going to produce a diagram to aid the working out that we're doing. I have two bodies on a straight road, the car and the caravan. I'll label them C and V. And then we'll add in all the forces that we know should be in play. So I've got a driving force. I've got a connection, which is either going to be a rope or a tow bar. And then I have resistive forces. The question actually told us it was a tow bar. At least it mentioned that in part A. And I know that the force, if it's accelerating, is going to be tension. So there's tension in this tow bar, which I can just represent like this. And the direction that we're moving is to the right. The two resistive forces we don't currently know, but we could find them with the information we've been given. We know that those forces are going to be in the ratio of the masses. Let's add the masses to the diagram. We've been told in tons, but I'm going to write these in kilograms. 750, 1,250. So that being the standard unit for mass, I've made sure to convert tons into kilograms. Well, what ratio are these in? So 750 to 1,250. I hope you can recognize 250 as a factor. So they're in the ratio 3 to 5. Well, if they're in the ratio 3 to 5, we were told that the resistance to motion is going to be in the same ratio. So 1,200, I need to share that out in the ratio 3 to 5. 1,200 divided by 8 gives me 150. And then we can just multiply these out. The resistance on the van is 450. The resistance on the car, 750. Okay, I can add those to the diagram. From here, we should actually be ready to try and find some of the other unknowns. We were given some other information that I could make use of. It's the last sentence in the first paragraph. The car and caravan accelerate uniformly from rest, from a zero velocity, to 25 meters per second in 20 seconds. All of this information can be put into a SUVAT formula. We were told the acceleration was uniform, which means there's constant acceleration, and our SUVAT formulas are our constant acceleration formulae. Okay, so just substituting those values in. Initial velocity of 0, we get up to 25, we're looking for the acceleration, and the time was 20 seconds. So the formula to use, V equals U plus AT. And let's just substitute those numbers in. A little bit of rearranging gets us a value of A of 5 over 4. Okay, so the acceleration is 5 over 4. SUVAT and Newton's second law, constant acceleration and Newton's second law, are linked by the acceleration variable. Now that I know the acceleration, I can start to think about Newton's second law, F equals ma, and how that can help to find the unknown tension and the unknown driving force. So I'm going to start with the caravan, since there's only one unknown, being the tension. So Newton's second law says that the resultant force, so a combination of the forces in the direction of motion, considering positive and negative, which in this case is t minus 450, should equal the mass times the acceleration. Okay, just rearranging to make tension the subject, and we get a tension of 1,387.5. Okay, so that's the tension in this system. We can now move over and think about the actual car. So, once again, Newton's second law needs the resultant force. So that's all of the forces acting on the car. So we'll do D minus 750 minus T, and that should equal the mass times the acceleration. We now know what the tension is. Let's go ahead and substitute in the tension. and just through rearranging, we should get a value for D. Now, I haven't touched my calculator at all up to this point. I'm just writing the values that I'm going to type in, and I'll just type it all in at once. I know this should be the correct calculation, and we get a driving force of 3,700 newtons. Okay, so a nice question that actually involved constant acceleration formulae, that's SUVAT. It involved Newton's second law, that's our F equals ma, and it involved some ratio right at the very beginning of the question. All of this would have been hard to access without a good and well-labelled diagram.